Hello children, let's understand physical properties of metals. Yes, so do you know metals are really important? Yes, they are important for making airplanes, for making bridges, buildings, for the construction materials. It is used for daily processes. We use jewelry which is made up of silver and gold, right? Even we do reactions in chemistry with lot of metals. Have you seen zinc granules, magnesium ribbon in your chemistry lab? I'm sure you have seen those. So, what are the physical properties of metals? How can we say that, see, this is metal? So, let's understand the physical properties with some very important activities. So, children, the activity we have here is metals have lustrous appearance in pure state. Children, what is the meaning of lustrous appearance? Lustrous means shining appearance, shining surface. So, do metals have shining surface? See these metals. Do they have shining surface? Look at copper, how beautifully reddish brown luster it has. Silver has a greyish appearance. Then this is iron, this is gold. How beautiful luster they have. So, they have shining surface. That is, they reflect light when strike on their surface. And see, how do we do the test? How do we detect that they have shining surface? So, for that activity, what we will do, we will clean the surface of the samples using sandpaper. So, this is how we do. We take a sandpaper, we rub on the surface of these metals, and if they show a shining surface, it will prove that they have lustrous appearance. So, which samples that you can use from the chemistry lab? You can take iron nail, you can take iron nail, you can take magnesium ribbon, or you can take copper wire, or else you can also take zinc granules, right? So, we have lot of options that you can take from daily life also. If you have silver and gold also, obviously you can test for that as well. But yes, there are many metals we have in the chemistry lab. You can perform with any metal and you will find that they all have beautiful lustrous appearance. I hope you have understood this activity. So, metals are hard. This is what we want to prove. How we will prove that metals are hard? For that, you can take samples of any metal that is there in your chemistry lab. Like you can take iron nail, you can take magnesium ribbon, or you can take zinc granules. And what you have to do? You have to just cut the metal samples using a sharp knife. And what do you think what should be there? Actually, you will observe that knife is unable to cut the zinc granules easily, and it is very hard to cut even iron nail. So, it's very difficult to cut. It means they are very hard. But there are exceptions, children. As you can see here, the sodium metal can be easily cut into pieces. Why? Why is it possible? Not only sodium, children, sodium, potassium, lithium, they are considered as soft metals. Yes, why? Because they can be cut easily with a sharp knife. So, other metals are actually hard metals, but these are exceptions. So, I am writing here, these are exceptions to hard metals. They are soft metals. So, if there is a question, children, that name any soft metal, the answer would be either you write sodium, potassium, or you can write lithium, right? Now, usually metals are hard. They are hard to cut by using a sharp knife. I hope you have understood the activity. Let's understand this important activity. This activity will prove that metals are malleable. So, the question arises, what is the meaning of malleable? So, children, have you ever seen aluminium foil? See, this is aluminium foil, right? Have you seen aluminium foils? Have you seen sheets of iron? So, these are iron sheets. Have you ever seen gold coins or have you seen gold biscuits? So, what you can see here, this is gold. It can also be converted into thin sheet. So, this is gold, right? You can convert into gold coin, right? So, if the metals can be converted into thin sheets by using a hammer, so such property is known as malleability. So, children, what is malleability? The property by which metals can be beaten into thin sheets. So, is this a thin sheet? Definitely it's a thin sheet of aluminium metal. So what do we have to do in the activity? It's a very simple activity. Just strike the surface of the metal samples with a hammer. You can take any metal and you have to strike the surface with the hammer, and you will notice that gradually it is converting into thin sheet like aluminium foil. So the texture may vary, it depends on how much pressure you are exerting and if you are heating or not, but still if you are just exerting pressure by hammer, you will find that it will start converting into thin sheet. So this is the very simple activity. Can we say that metals are malleable? Yes, they are malleable. That is, they can be converted into thin sheets. Hello children, let's understand this activity. The activity will prove that metals are ductile. Yes, what is the meaning of ductile, children? Ductile is the property by which we can convert any metal into thin sheets. So, ductile is the property in which metals can be drawn into thin wires. Have you seen wires of copper or aluminium? Yes, even if you see the jewelry made up of silver or gold, are there gold chains? Are there silver chains you have seen? Definitely yes. So they can be converted into chains or wires, right? So see, this is copper metal. It is converting into copper wire. We can do that. And what is this? This is iron wire, and the same color is for aluminium wire. So when metals can convert into these wires, the property is known as ductility. So what do you have to do in this activity? Strike the surface of metal samples with the hammer, or you just have to put it from the machine where it will convert or mold into a wire. This is just the process that you have to do, and you will find that they can easily convert into thin wire. So there are many wires at your home. Have you seen any wire? Yes, the wires which are there in our household connections or circuits, they are mostly copper wires. And the wires which passing electricity from the powerhouse to your houses, they are usually made up of aluminium wires or copper wires, because one and the major point is that they are ductile, that is, they can easily convert or drawn into thin wires. Not only that, they are good conductors of electricity, that's why they are used for transmission lines. I hope you have understood. So here we have to prove that metals are good conductors of heat. So are they good conductors of heat? Have you seen any example of any metal which is a good conductor of heat and you are using it at your home? Yes, all the utensils, children, all the cooking utensils, they are good conductors of heat, aren't they? Definitely yes, because those are made up of metals or their alloys, and ultimately because they are good conductors of heat, therefore we are able to use them as cooking utensils, right? So what are the metals that we usually use for cooking utensils? For making cooking utensils, we use copper, aluminium, iron, right? Because they are good conductors and actually non-corrosive. So they also have high melting point. So how will we prove that they have high melting point and they are good conductors of heat? So for that, you need to have such experimental setup where we have taken a clamp stand. So see, this is written clamp, stand, and then we have connected a metal wire here. So this is a metal wire, or you can take metal rod, and then you have to put a wax here and place a pin. Now what is the purpose of placing a pin? I will explain that, and then start heating using a burner. So what will happen when you start heating a metal wire using a burner flame? So children, gradually you will find that this metal wire is getting hot, and if it is getting hot and if you will touch the pin here, so this pin, if you will touch this pin, you will find that this pin is also getting hot. How is it possible? Because metal is a good conductor of heat, and if it is a good conductor of heat, it will transfer heat from one point to another point. See, we are heating from this end and the heat will transfer to this end, the free end. And not only that, it will also transfer to the pin, because pin is iron nail and it is also made up of iron and a metal. So it means that metals are good conductors of heat. And will you find that it will start melting? No. Metals have very high melting point, they will not melt easily. Therefore, the metal wire will keep on heating, but it will not melt easily. Hence, it is clear and proof that metals are good conductors of heat and they have high melting point. So children, there are very good conductors of heat, and those good conductors are, what are the good conductors of heat, children? Any guesses? So the best conductor is silver. Ag is silver, followed by copper. They both are very important and good conductors of heat. Though all metals are good conductors, but silver is the best, followed by copper. Then there are poor conductors also. Yes, there are poor conductors of heat. And which are those poor conductors, children? For example, poorest conductor of all is lead. Pb is lead, right? And followed by mercury. So they are poor conductors of heat. Now, you will be surprised to know that we do have exception here also. What are the exceptions? You know, all the metals have high melting point, but there are exceptions. The soft metals, they have low melting point. They have melting point below 100 degrees Celsius. So, sodium and potassium, they do have low melting points. Not only that, cesium and gallium. Cesium and gallium. Cs is cesium and Ga is gallium. Cesium and gallium, they have very low melting points such that if you keep them on your palm, they will start melting. They will absorb heat from your palm, from your hand, and then they start getting melted. So, they have very low melting points. So, again we have exceptions in the metals melting points. So, what are the exceptions, children? The exception is cesium and gallium, they have very low melting point, while rest of the metals, they have high melting point, right? This activity will prove that metals are good conductors of electricity, aren't they? Have you seen copper wires and aluminum wires? They are good conductors of electricity. That's why they are used in transmission lines. So, it's a very important reasoning question. Why do we use copper wire and aluminum wires for electrical transmission? So, any guesses, children? What is the main reason? So, electrical transmission means the substances must be good conductors. So, definitely all the metals, they are very good conductors of electricity. So, copper and aluminum wires, they are good conductors, right? They can easily pass current or electricity through them. So, that's why we call them good conductors. Not only that, they are making wire, right? So, wire, what is this property of drawn into a thin wire? This property is known as ductility. So, these metal wires, they are made up of copper because they are ductile. They can convert easily into thin wire, and further, they are economical. Are they economical? Definitely yes. So, copper and aluminum, they are economical, they are cheaper than other metals. So, that's why we use copper mainly, and it is abundant in nature. So, on the basis of their abundance, their costing, we use these wires for electrical transmissions. Now, what is the activity? What do you have to do in the activity, children? In this activity, you have to do this circuit, right? You have to make this circuit in which you can see there is a battery, there are clips. These clips are AB, where we will insert the sample to be tested. If we are going to test aluminum wire, we will put aluminum wire in AB side, and then we are connecting it with the switch and the bulb. What will happen? What do you think? If you put aluminum wire here, what will happen? So, what are we doing? We are connecting a metal sample wire in the given circuit, and what will happen when you put aluminum wire here? As soon as you will put aluminum wire here, you will switch on the key. What will happen? The bulb will glow. So, what is the observation, children? The bulb will definitely glow. Why? Why the bulb will glow? What will it prove? It will prove that definitely this aluminum wire we will place here is a good conductor, because if it is passing current, then only it is flowing through the circuit and it is reaching to the bulb, and hence bulb will glow. So, this experiment is really easy, and what is it explaining? It proves that metals are good conductors of electricity, right? So, the best conductors of electricity is definitely silver, followed by copper and poor conductor is lead and mercury. Now, I also want you to ponder over this. If you look at this wire, see, this is yellow colored wire, right? Is it really yellow from inside? So, if you cut the wire and look inside, is it a yellow wire? No, it's actually a copper wire inside, which is reddish brown in color. So, why there is a coating here? What is this insulation or coating here? Have you seen red colored wire, green colored wire, blue colored wire, or maybe some other color? So, what is the purpose of this coating here? What is it doing? This coating is actually helping us to prevent us from electric shock. Yes, how is it possible? So, children, coating is usually made up of PVC. Yes, what is the full form of PVC? PVC is polyvinyl chloride. Vinyl chloride. And what is the use of PVC, polyvinyl chloride? Children, polyvinyl chloride coatings are a good insulators. Yes, they serve as insulators. That is, they protect us from electric shock. What is the meaning of insulator? That they don't allow electricity to pass through them. So, the copper wire will passing the electric current, but that copper wire is insulated with a cover, and when we touch the wire, we will not get shock because it is covered with some insulation. So, that current which is flowing into the copper wire will not touch us, and hence it will prevent us from electric shocks. So, keep it in mind, this PVC coating is really important for us. So, children, now let's proceed further with the next property of metals, and which is metals are sonorous. So, do you know the constituents of school bell? Yes, this is the school bell. It may be like this or maybe round shape, but still this school bell is actually made up of metal. And do you find any sound when it buzzes? Yes, so when it hits, it will definitely get a rhythmic sound, right? Not only that, look at this picture. What is this picture for? So, it's the orchestra drummer, right? What is it doing? It is actually beating the drum, and not only that, it is also beating the metal. See, the metal bars are here. So, when he is beating the metal bars, it is actually producing a beautiful sound. So, metals are sonorous. What is the meaning of sonorous, children? They produce sound when we strike them with a hard object. Do you hear any sound in your home when there is a bell rings at your door? Definitely yes. Again, the bells at your home, they are made up of metals. So, metals are sonorous. Right? So, when we conclude all the activities, what are the physical properties of metals that we can jot down? So, the physical properties of metals are, they are lustrous. What is the meaning of lustrous? They have shining surfaces. They are hard and rigid. Is there any exception? Yes. So, they are hard, but there are soft metals. And what are the names of those soft metals, children? The name of the soft metals are sodium, potassium, lithium. They can be cut with knife. Then there are malleable metals. So, metals are malleable means they can be converted into thin sheets. Yes, they can be drawn into thin sheets or beaten into thin sheets. Then what is ductile? Metals are ductile. The property of ductility means they can be drawn into thin wires. Then they are good conductors of heat. Yes, they are good conductors of heat, and they are good conductors of electricity. The best conductors of heat and electricity are silver and copper, and the poorest conductor is lead. Then they have high melting point, but there is an exception. Low melting point metals are, any idea, any guesses, children? Low melting point metals are cesium and gallium. Cesium, C-A-E-S-I-U-M, cesium. And what is gallium? G-A, either you write double L or single L, that's okay, but this is gallium and cesium. Then they are sonorous, that is they produce sound on beating. Do you know the physical states of these metals? Yes, all these metals are solid in state at room temperature. But again, there is an exception. There is an exception which is liquid metal. Do you know any liquid metal? Have you ever seen the metal there in thermometers? What? There is a metal in thermometer? Yes. Thermometer contains mercury, and mercury is a metal. So, can we say that there is a metal which is liquid at room temperature and that metal is mercury, Hg. What is Hg? Mercury. So, children, you must know the exceptions of all these properties as well. And now, let's look at the animated video for all these activities for the better understanding.
Take aluminium, zinc, iron, and copper metals in the form of thin pieces and perform the activities. Note the appearance of each metal. Now rub their surfaces with sandpaper and again note their appearance. You find that metals in pure state have shining surface. This property is called metallic luster. Try to cut each metal with a sharp knife. You find that metals in pure state are hard and cannot be cut with a sharp knife. Hold the pieces of each metal in a flame of Bunsen burner with your hand. You find that it is not possible to hold the metals while in the flame. Thus, we can say that metals are good conductors of heat. It is on account of this property the metals are used for making cooking vessels. Set up the electric circuit. Insert each of the metal in between the clamps A and B and switch on the circuit. You observe that bulb glows in each case. Thus, we can say metals are good conductors of electricity. Strike each of the metal pieces on some hard surface. You observe that all of them produce a peculiar metallic sound. We can say that the metals are sonorous. Place a metal on iron block and hammer it number of times with a hammer. Repeat the procedure with other metals. You observe that the pieces of metal flatten. The property of metals by which they could be beaten into sheets is called malleability. Do you know that gold and silver are most malleable metals? The thin leaves of gold and silver are used in decorating sweets as well as making Ayurvedic medicines. Figure out amongst the metals aluminium, zinc, iron and copper which are available in the form of wires. You find except zinc, rest are available in the form of wires. This property of an element by which it can be drawn into wires is called ductility. Most of the metals are ductile.
So, as you have seen this animated video, I'm sure now the concepts are very much clear that these properties belong to metals. Metals are lustrous, hard, malleable, ductile. They are good conductors of heat and electricity. They have high melting point. They are sonorous and they are solids at room temperature, obviously with some exceptions. I hope the concept is clear. Thank you.